I had in the previous module talked a little bit about a very brief introduction to Python, and for those of you who've not been programming before, I wouldn't worry too much, because in this principle of learn as you go, Lego, like I like to call it, easy as a play game, we're going to pick up concepts as we go along. In other words, so long as you can run very basic lines of code, the rest we're going to pick up on the way, and that is part of what I want you to learn. Now, many of you are more advanced programmers, and for those of you, you can easily skip this video a little ahead if you like. The conclusion of this part, however, is an assignment. So if you already know everything, clearly do the assignment and you're done. So what is the assignment? That is indeed an introduction to Python as a tutorial to go over some basic concepts, writing some basic code, and being able to manipulate loops, file input output, and graphing. Your actual assignment is to complete the plotting of a histogram of the whole proteome dataset of E. coli. I will demonstrate this for only 9 proteins, and you need to modify my files, which I'm going to provide to you, to plot it for the whole proteome. Usually in a live class, I actually go over each of your code and explain to you what the problem is. But once you submit the code and if it runs, then I will give you feedback if there are any issues, and if it does not run, then obviously we will be discussing the answer in class. Right. So with all that in mind, let's get back straight to it, because coding is much more fun than talking about coding. So the way I run Python on my machine is through Jupyter Notebook. In order to get this, I went to my command line interface, where I typed Anaconda Navigator, and that triggered a navigator window. And what it does is, amazingly enough, it opens a browser window, and this is what you see here. This code, again, as I said, is being shared with you, so that should hopefully not be an issue. What you need to notice here is that I hope you see some nicely formatted text here, but if I click on it, it's called Markdown. So this is a browser, Firefox is what I use. Markdown is nothing but text, highlighted text. There's a syntax to it. A so-called second level heading is marked by double hash signs, and Bio 315 Cellular Biophysics, it auto highlights the text. And now I've written some explanation about what I hope this exercise is going to show you, that is to demonstrate basic aspects of Python programming, introduce you to plotting and basic arithmetic, and then characterize the protein database entries. So we have to start somewhere. Let's start with the simplest. Just a aside, so far these were markdowns. This is now code. So this you see over here in this window, that the cell, in other words, Jupyter divides the code flow into cells, contains some elements. They can be either code, markdown, raw NB convert, or headings, and we are only going to be concerned with code and markdown. If you're interested, please go back and look what raw NB convert and headings means. As I said in my introduction, Python has extensive documentation, and that's what makes learning as you go so much easier. I know some of you are on your phones, so this might be a little bit harder, but there's no rush. So in order for me to convert this markdown, this raw, ugly looking text into nice, beautiful formatted text, all I need to do is press run. Okay, so now it ran just this cell. So the code is divided into cells, and those cells are independently run. They can also be connected. So if I ran one cell and then had some information in which I wanted the next cell to run, then obviously it run them either together or in sequence at least. So let's look at the first cell here. I set a is equal to b, a is equal to 4, b is equal to 10, and use a magnificent giant computer as a simple calculator. And of course, I get the answer of a times b, this asterisk sign indicates multiplication, as 40. All good. So now I move on. I'm going to just sort of discuss a little bit of printing. What else can you print? And this is, print hello world is the first line that Cunningham and Ritchie put into their textbook. on C. And so welcome to Bio 315 is my message to you. Hello world, just for fun. And suffice to say, these are single quotation marks, these are double quotation marks, both of them work. I talked about this in class. Why do we bother writing a computer program for biological problems? The idea is, of course, clear. Simplify what is a labor-intensive, time-consuming, error-prone, subjective task, make it more automated, universal, improve confidence, data collection, analysis, representation is easier. And I talked about how you can do analysis and in silico experiments. So I'm going to go ahead a little bit faster. What you can do with the code is actually automated plotting and scripting, script for regression analysis, perform statistical analysis, model and simulate your data or hypothesis. Indeed, while we can use it as a trivial calculator of adding numbers and taking some outputs, we can do a bit more. So as you see, the sums over here are fine, and I can even do the same thing with strings. In other words, words or alphabets that are strung together to create words and even sentences if I want. So indeed, this is important at this point to bring up the fact that the data types that we are interested in are number, string, tuple, list, and dictionary. And number types or numeric types are plain integers, int, boolean, long integers, float point numbers, complex numbers. Booleans are some type of int, zeros and ones. I would really urge you, if you want to learn more about the numerical support provided by Python, to refer to the Python documents on numeric types. So you can also, of course, do division. So you can do addition, multiplication, subtraction, division. Now, the question is, depending on the version of Python you're running, and Google Colab for coding does have the latest Python 3, but if you had a local version of Python 2 point something, you will output a more complex data type even when simple integers are input, meaning to say that if I now, instead of 12 by 5, put 13 by 5 and run it, yes, indeed, I need to change it here. So instead of 125, if I put 121, yeah, so what you're seeing here is a truncation to the integer output. So this answer is not quite right, and we need to somehow find a way to get hold of it. And I leave this to you, and we will discuss it on our discussion session. What must you do to get the full decimal numbers or the so-called float values beyond the integer if you give a so-called not fully divisible number? Strings, on the other hand, are concatenated symbols, and this is an example over here of hello world. Indeed, strings have also positions, and as I said in my overview, it is all base 0. So 1, 0, 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12 onwards. So if I say A from the 7th element, that is base 0 onwards, to the last element, signified by this semicolon sign, will give you just the second part, world. If I now modify this to say from 2 onwards, for instance, you should see in fact 0, 1, 2 onwards, low world. Okay, so you can play around with this. Okay, please use it. Indeed, lists, which is kind of what we want to use for initially at least storing some of our data is a nice simple structure that kind of looks like an array but isn't an array because it's one dimensional, whereas arrays can be n dimensional. And as this variable states, if I put in some numbers 11, 21, 7, 23, 26, 1, 0, 1, 2, 3, 4, 5, that is 6 in length, and if I print it, I will actually get the numbers again, and type is the data type it is, and this actually tells me from the code that it is actually list. List elements can of course be individually accessed. I can call the length of the list. This is the command len list, or len of that list in brackets. I can invoke certain elements of that value, the 0th value for instance, the first in that sense. I can even call other values of it. So let us say I want to find out the last value. Will this work? So let us see. My last value, remember, is 1. So if the length is 7, the last value throws an error. This, remember, is because of our base 0 rule. Now suddenly my last value is correct and 1, right? You can also use a so-called negative index, which is, so what do you think the negative index will give you? So if you look here, of the value at x of -1 is 1. In other words, it was the last value. -2 is the last but one value, which is 26, and so on and so forth. Try it out yourself and you will find out. In that sense, the indices are wrapped around, right? You go around and you go -1, -2, -3, etc., etc. That is not base 0. Yes, you're right. The first 3 elements, for instance, or the first n elements are 0 to something. That's why the colon, the semicolon. And I hope you remember this, that that we'd used the colon earlier to give an open-ended range also, everything from something to something else. Range is a built-in function which allows you to create a series of numbers in a, let's find out what kind of a structure, right? It's a range, right? And the size of the range is indeed its length, and for each value in that range, we can actually iterate. In other words, we can pass values to the for loop, and it will just simply go through every element from 1 to 10 with a step of 1 to list it out. Now you notice that 10 is a non-inclusive limit. In other words, it stops 1 minus that, or 1 increment above. So you can say here we have range smallest value, largest value minus increment and increment, meaning to say increase by 3, increase by 2, increase by n. That value minus the largest value is what the last value of the, I'm sorry, plus the increment will be as it is output. Okay. So in other words, if I want to range from 1 to 10, actually including 10, then I need to add 1 here, and then I will get my 1 to 10. Okay. So combining ranges and lists can all be useful. So I can say x double star 2 for x in range 6. So x in range 6 is like we did here. So let's look at this. Yeah, range 6, right? is 0 to 6 with increments of 1. X double star asterisk 2 is square of that. So 0 is 0, 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25. Familiar to you. So it's a very quick way to get us a range containing some arithmetically manipulated values. Sets are a container in which then sort and repeat the values, keeping tabs on what is unique. Now here you see a set which is 1, 2, 3, 1, 3, 4, 5, 10, 11, 4, 5. What you should hopefully notice is there are a few redundant numbers, meaning to say repeated numbers. So when I just print the values, what do you think I get? Okay, so if it was an ordinary list, right, then I would get everything, yes, which is this. But set finds the unique values in that and puts it out. In other words, the length of the set 1, 2, 3, 4, 5, 6, 7 is 7, but the length of the list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I can even maybe create a list and attribute it to set and try and find the so-called unique values. You can also mix up types, strings, integers, and floats, and combine them. So for instance, I want to combine the word string with an integer and a float, and let's see if it works, right? So string gives string, string, p plus p, p plus q, which is string plus integer, gives me what? Let us see. An error. Huh? So that doesn't exactly work. Q plus R gives me a command which does indeed work. Q plus R, so integer and string can be added. I'm sorry, integer and float can be added, but a string cannot be added to either an integer or a float, as we saw earlier. Try it out yourselves if you don't want to believe me. And this is the beauty of it. I want you to be able to try these things out. Now what you see in the last bit I want to talk about over here are for loops and if-else loops and while statements. In other words, something that iterates. So for statements are given as x in values something. So in some either a range or a list or something. This will allow you to print that value. If-else statements need to be structured as some criterion, some comparison. If x is less than 0, do something. If elif, not else if, but elif, x is greater equal to something, colon, print 0, elif, and then so on and so forth. Or while statements, which are a little more dangerous unless you use them carefully, where you initialize your value I is equal to 1 while I is less than something, print I and increment it so that it stops just one short of that. So this is also, these are the standard looping syntaxes which you've seen probably in various places. What if we want to access some values one by one that are in an array? Remember, we created a list, a list somewhere called values. So we said values are a range from so and so to so and so. So let's see if we can access each of those values using our for loop. And lo and behold, by just simply saying for v in values, which is that list that we gave it from range using the function range, we could actually access each one by just simply invoking an element in that iteratively. The iterator for actually is very clever in that sense in Python. So now if something else and while statements can be easily structured, you think of it logically. Pick a number between something, create some integer value of that number, meaning to say make it into a type that we can deal numerically. You can either create it as integer, try creating a float out of it, and see what happens. And if that value that you input, you yourself or your friend whom you pass this code on to, is less than some criterion, print less, greater than some criterion, equal, or you want to say invalid input, so that's what to do. So let's see if this runs. Pick a number between 1 and 10. It has to be in integer according to my definition. So I pick 4. It's indeed less than 10. Sum of 1 until that number is what I calculated using my while. So while the counter is less than or equal to n, where n is some cutoff or set point value, then just count the number of increments. So so how many values until I reach my criterion? Yeah. There are many Pythons packages, so SciPy, NumPy, and other Pys, and you can read more about them on scipy.org for SciPy, and NumPy is a part of the core packages, has numerous functionalities, SciPy library, matplotlib, some enhanced consoles, and data structure and data import output packages like pandas. Yeah. So we're going to start with the most simple exercise of a stochastic problem. Yeah. You remember I said we can do two things. We're going to basically analyze data and we're going to simulate processes. For the analysis part, I'd like you to focus on a stochastic problem of coin flipping, and I'll talk about it next.